Okay, so let's talk about the laws of logarithms. Now, these laws also apply to natural logs as well. Okay, so first of all, let's take a look at the first law, right? The product rule. Okay, so basically, what this rule says is if you have a log, all right, with any base, all right, and two terms multiplying with each other. Okay, now here's what I want you to remember. So these values you can think of this as like over 1. Since these values being multiplied with each other are in the numerator, when you separate them into multiple logs, the logs will be positive because the x and the y are in the numerator of this value right here. Okay? So let me just give you an example. I think it's easier to understand with an example. Let's say we have log base 2, all right, of 5x. If I were to separate this or expand it, as we say, into multiple logs, this would be equal to, all right, log base 2 of 5, right, plus log base 2 of x. Now you notice both of these logs are positive because if you think of this 5x as over 1, since the 5 and the x are in the numerator, that means their logs should be positive when you expand it. Okay? Now this also applies to natural log. Let's say we have the natural log, right, of let's say 3y. If I were to expand this, this would be natural log 3 plus natural log y. So you notice it's the exact same thing. It's just that it's a natural log instead of the word log. Okay? So that's the product rule. Let's take a look at the quotient rule. So the quotient rule says this. So it says that, okay, if this is division, right? Now here's the main thing I want you to remember. If you have something being divided and the denominator, right here, this denominator value, if a term is in the denominator here of a log, right, that means that when you expand it, the log should be negative. Okay, so you notice here, this y here, the log for it is negative. That's because this y is in the denominator. Okay, so I'll give you an example. Let's say we have log base 4, right, of, let's just say, 7 over x. If we were to expand this, this would be log base 4 of 7. Now you notice this log is positive. Why? Because the 7 is in the numerator. Now the x is negative, right? So we would have a negative log. So this log is negative, log base 4, right, of x, right? So since the x is in the denominator, the log for it when you expand it must be negative. Okay? Same way, let's say we have this log base 3 of x over y times z, right? Y times z. So if we expand this, this would be log base 3 of x. This log is positive because the x is in the numerator, minus, all right, log base 3 of y, and then minus log base 3 of z. All right, you notice these two logs are negative, right? These logs here are negative because the y and the z are in the denominator here. Okay? So, real easy. And if you have a natural log, it works the same way. And I'll give you an example right now with a natural log. Let's say we have natural log 5 over y. If we were to expand this, it would be natural log 5 minus natural log y. So the natural log is negative because the y is in the denominator. Okay? So just remember, if this value is in the numerator, the log should be positive. If this value is in the denominator, the log should be negative, right? Or natural log. Okay? And then the last property we need to know, right? So this one here is the power rule, right? So the power rule. So this says that, well, if we have exponents involved, so let's say if we have an exponent right here, basically what it says is we are allowed to move the exponent to the front of the log and multiply it with the log. Okay, let me give you an example. Let's say we have log base 3, all right, of 2 y to the 4th power. So this rule says that, well, we're allowed to take this exponent and move it to the front of the log when we expand, right? So I'm going to expand this, okay? So you don't want to move it to the front right now, right? Because you have to think of these as two separate terms. This is a 2 times a y to the 4th. So when I expand this, this is going to be log base 3 of 2 plus 4, all right, log base 3, right, of y. So you notice I moved the 4 to the front of the log here, right? So the 4 got moved to the front of the log. Okay, so this exponent got moved to the front of the log when I'm expanding. Okay? Let's try another example of this. So say we have log base 6, and over here let's say we have x squared y to the 4th, right, over z. If I were to expand this, all right, we're using multiple rules now. So when I expand this, this would be 2, right, log base 6 of x. So you notice this 2, the exponent for the x, gets moved to the front of the log. So this 2 is multiplying with this log now. And then I have plus 4 log base 6, all right, of y, right? You notice both of these logs are positive because the x and the y are in the numerator. But the z is in the denominator, so I need to have a negative, and then I have log base 6, all right, z. Okay? So those are the three log rules, all right, that you want to apply when expanding and condensing logs. Let me give you another example right here, all right, with a natural log. So let's say we have a natural log 4, right, over x y to the 3rd. So if I were to expand this, this would be natural log 4 minus natural log x minus 3 natural log y. So you notice that these natural logs are negative because the x and the y to the 3rd are in the denominator here. Okay? And if we have any exponents, we move it to the front of the log. Okay? Okay, so let's take a look at some examples now. So we're going to use those log properties to expand these logs. So when you're expanding, you have a single log, and you're going to rewrite it as multiple logs. So this first example here, we would have log base 2 of 3 plus 4, right, times log base 2 of x. Okay? For b here, now if you have something that's in third form, you want to change this. So this we know is y to the 1/2 power. So now when we expand it, we're going to have natural log x minus, plus 1/2 natural log y, and then minus natural log 2. Okay, so you notice these two natural logs are positive because the x and the y are in the numerator. The 2 is in the denominator, so that's why the natural log is negative. Okay, this one over here. Now remember, if you don't see a base written by the log, there's an imaginary 10 here. Okay, so anytime you don't see another number here, you know that there's an imaginary 10 there. So you don't need to write the 10, but you can if you want to. So if we expand this, this is going to be log 4 plus 3 log x, right, minus 2 times log y minus log z. Okay? Now let's go the other way around. Sometimes we need to write as a single log or condense. Okay, so let's take a look at this example now. So this time we need to make it into one single log. Okay? So we need to take all this and make it into one single log. So we have log, we have the x here. Okay, so the x. I notice this log is positive, so remember this number in the front becomes the exponent of this guy. So we have x times y to the 2/3 power, right, 2/3 power, And then this log is negative, so that means that z, right, over here is going to become the exponent of the 3. So we have 3 to the z power, right, in the denominator, right, because that log is negative. Over here, we have a log. So this value becomes the exponent here for the x. So we're going to get x to the 4th. This number becomes the exponent for the y, but this log is negative, so it's got to go in the denominator. We have y to the 1/2, and then also z to the 2nd power, because this becomes the exponent for the z. And the z is in the denominator because the log is negative. Okay?